The broadcast is now starting. All attendees are in listen-only mode.
Welcome to this new SIGAL video. Today we are going to talk about Blueback Seismic Reservoir Characterization, and more especially about EEI classification and Chi angle stacks. So first of all, thank you for signing up. We plan to run this session over the next 3 weeks again, so please sign up. If you want to add more videos at the end, please tell us what you want to see. We can add more. If you want to find out more about any Blueback tools, please contact your SIGAL account manager or email us to sales@sigal.com. The format of these videos, each session will last between 20 and 30 minutes. Each session will be recorded and you will get a copy of the recording via email 24 hours after the webinar ends. The recording will also be loaded on the SIGAL YouTube channel. And if there is time for question, can you please submit a question via the chat tab in GoToWebinar console. So let's jump into today's video. So our situation is we have angle stacks, so here near, mid, and far, and we want to analyze potential Chi projection that highlight fluid and hopefully lithology. And the purpose will also be to use this volume for the Seismic NetPay video that we will run on the 15th of April. So challenges, first, it will be to determine the best Chi projection for lithology and fluid at the well. Then it will be to determine if we have the same apparent Chi in the seismic dataset. Spoiler alert, no. Today we are going to follow a workflow, a two-part workflow. First, we will analyze our EEI Chi analysis at the well, and then we'll focus on the seismic, first with the creation of intercept and gradient, then with the color inversion of our intercept and gradient, and then we'll analyze the Chi projection in our seismic dataset. But let's jump into Petrel. So this is our dataset. We have seismic data with near, mid, and far. We have one surfaces, which is here our top reservoir, and we have in this dataset one well. For this well, we have all the suite of well logs that we need. So here porosity, VP, VS, V-shale, water saturation, gas saturation, and facies. So first, I'm going to analyze the Chi projection at the well. To do that, I'm going to go to Blueback Seismic Reservoir Characterization, which is located in Marina. So Seismic Reservoir Characterization, or SRC, is composed of different tools. Each tool is independent, but they can be used in a workflow. If you select about Blueback Reservoir Seismic Characterization, you have different workflows that we can propose, but this is just a proposed workflow. So first, I'm going to go to EEI angle analysis. For each tool, you have two tabs. First, the tool, and then the help on the second tab. So the help is always close to you. So first, in this tool, we have to select our well input. For this, in this project, I only have one well, so I'm just selecting my well. I'm going to select a zone of interest, which is just where I have dataset in my project, so in my well. So this is the zone that I'm investigating. Then for the calculation of AI and GI, I can use VP, VS, and Rho, or use AI GI that I might have in my project. For today's video, I'm going to use VP, VS, and Rho. Then you need to click on average from log because you need to calculate the K parameter, which is needed for the calculation of GI. Then we can select different log to color our data. So first, I'm going to select a water saturation, for example, and a facies. And then I can click on refresh over there. So now on the right-hand side, I have my plot with my data plotted in this plot. I can select my legend, and you can see that at the moment it's colored by well, by dataset. I can now color by facies, for example. So here I can see that I have my shale in gray and my sand in orange. In this plot, you can also find an arrow and a plane which correspond to our chi projection. To manipulate the chi projection, you can manipulate it using the cursor or the slider over there, or you can type if you wish to. To analyze the chi projection, you can see that you have an histogram at the bottom, which is the chi projection along this plane over there. So one way of finding the best chi projection is to run through different chi projection, like so, for example. Another way of analyzing our data is to click on Advanced. And here we have new options. So for example, log correlation. So I can now select a target well. So for this purpose today, for the video today, I'm going to focus only on my water saturation. And here the tool has calculated for each chi projection the cross correlation between the EEI chi log, which for each chi projection, and our water saturation log. On the right-hand side, I have now a new tab where I can have more QC. So I select my well. To have more context, I'm selecting some well tops. So my reservoir is this section. And now you can see that I have the tops over there. And then on the track number 2, I have 2 logs. In black, I have my water saturation log, which is coming from my well data. And in black, I have the EEI chi projection log, so here 30. The purpose of this tool is to find the best chi projection or best EI log that mimic the behavior that we want to analyze, here our water saturation. So if we look at this cross plot, we can see that the maximum cross correlation is around 27 or 30. So for this data set, the best chi projection for water saturation is around 30. If you want to see this water saturation also in the cross plot, you can change your color and color by, water saturation if you wish to. You also have the possibility to bring some seismic correlation. So here you can bring intercept and gradient. I will show you later in the video how to create intercept and gradient. So I'm bringing intercept and gradient. And now I have on the third tab over there some seismic synthetics. So first to create the synthetic, these 3 regal, I need a filter. So by default, these are those values. But if you open this tool, you have the possibility to find the spectrum of your intercept and gradient in order for your synthetic to have a similar seismic broadband. I just need to find the spectrum. I've selected 50 traces, so the tool will look into my seismic data, so intercept and gradient, and analyze the seismic spectrum on 50 traces. So here I have now in as a wavelet my filter in black, blue intercept, and orange my gradient, so I can zoom in, zoom out. And here I can change the frequency filter, my corner points for F1, F2, and F3. So now I can have something better and more similar to what I have. And now you can see that it has updated. You can also select the cross correlation, and here right away you can see that we have the maximum cross correlation for the seismic dataset is at 15. So it means that the best chi projection for the seismic dataset to highlight the water saturation is at 15. This is the first hint of the potential difference that we can have between the best chi at the well and the apparent best chi projection in the seismic data. The reason is we have in our seismic data noise that we can't quantify. So it's good to analyze the chi projection at the well, but do not hesitate to screen for chi projection in your seismic dataset. It's what we are going to do. So here, once you have our best chi projection at the well for water saturation, so around 25, you can do the same with another parameter. So for example, V shell or gamma, if you want to analyze the best chi projection for lithology, but we'll not do it right now. So once we have, I'll just go back to my workflow. We've done our EEI angle analysis for the well. The next step is to jump into the seismic data by first creating an intercept ingredient. So the tool intercept ingredient is also located in Seismic Reservoir Characterization, and we just have to select this tool. For this tool, you just have to select your angle stacks, so near, mid, and far. Near, mid, and far, just select them, and then you can bring them in the table. For each angle stack, you have to specify the central angle. You have different methods, so for example, Chouet, Burfield, Fatty, and so on. And each method has, you can have the name of the paper where it comes from. You also have the equation. For each method, you also have some different regression for two terms, least square, total least square, reduced major axis, well-done robust, or matrix inversion. So here for this purpose, I'm just selecting two terms and the regression of least square. Once you click apply, the tool will create under the first angle stacks a new folder called Seismic Intercept Ingredient that now can be displayed in a new window. So I have two windows prepared. On this, I can select my intercept, and here is my gradient. The next step of my workflow, just bring the workflow over there, is to do the color inversion. So I'm going to do the color inversion for my intercept and gradient. To do that, I need to go to color inversion operator design. This tool will allow me to create two operators, one operator for my intercept and one operator for my gradient, in order to do my color inversion. So the color inversion has two purposes. First, to filter, and then to change domain from reflectivity to impedance. So the tool has different tabs at the top. First, you need to select your well for your well spectrum. Again, I have only one well here. You can select well top if you wish to narrow down your zone of investigation, and then the tool needs an impedance log. So we have an AI log, but the tool can also create an AI log using VP and row. Then we go to the second tab, and to have our average seismic spectrum. So once we're going to create, because we want to create the operator for our two volume, it's one volume at a time. So first, this video, I'm just going to create an operator for my intercept, but in real life workflow, I will have to do it twice, one for my intercept and one for my gradient. Then, so I've selected my intercept, then I go to select some traces. So first, I'm going to narrow it down. I'm going to use a top reservoir with 5 milliseconds above and 500 milliseconds above and 500 milliseconds below to be sure that I have at least 1 second of data. And I will use 100 random traces. So now the tool is going to calculate, and it has calculated my seismic spectrum. For here, I forgot to click recalculate, so I don't have my well spectrum. So now I have my well spectrum and my seismic spectrum. If I look at the bottom, I have now this plot with some data. In red, this is my seismic spectrum coming from my intercept. In blue is my well spectrum coming from this well. In green is my operator, because by default, the tool has values for my operator. And in orange, it's a convolve result using this operator. So here now we have to parameterize our operator. You can do it by just typing values and seeing the result over there. But what we highly recommend is to go to Save Operator and use the Test Seismic attribute. So this tool will create a virtual attribute, a virtual volume, that will allow you to parameterize your operator on the fly. So this is now my intercept color inverted. So let me select just a line where my well is, so it makes sense. So now I have the line with my intercept color inverted. I have my top reservoir over there, my well with facies log highlighted to add some context. So now the purpose of the tool is to highlight some behavior. So either fluid or lithology, for example. So here I can go to operator shipping and change my parameters. And you can see that on the interpretation window is changing on the fly. So what we recommend is to put F1, F3, and F4 in the middle range of your seismic, so of your seismic spectrum. So for example, at 50 and 75, and then focus first on F1 and F2. What you want to do is to push F1 and F2 as low as possible without losing definition in your reservoir. If you lose definition in your underburden, you're not interested in your underburden for now. So focus on your reservoir. Once you're happy with F1 and F2, you can then focus on F3 and F4 and push them as far as possible, again, without losing definition. You want to highlight your features in your seismic dataset. Once you're happy with your F1, F2, F3, F4, you can go to Save Operator. You can scale it either to seismic or impedance, and you can save your operator as a wavelet, as a spectrum, or you can also save the spectrum of the convolve result. Then you can select a folder, you give it a name, and you click Apply. So this will have, you will then save your operator. So this is the operator I've created earlier. So if you open it, because it's now an object in your input tree, it's saved in your project. You have in the comment all the parameterization that you've used. So for example, the well that you've used, the seismic used, which operator you've used, and for example, the zones for the spectrum and so on. If you go to settings, you have the wavelet, the phase, and the spectrum. And if you go to value, you can then, you have the value for the operator, you can save them or export them into Excel, for example. Once we have created our operator for intercept and gradient, we can go into convolve tool. We select our operator, our seismic. So here my intercept. The tool works with 3D or 2D. You just have to toggle between the two if you wish. And the tool can normalize if you wish to and add low frequency data. For the output, you can either create a virtual output by just clicking here, and it will create a virtual output under the intercept. Or if you don't do it, you can just give it a suffix and it will realize the volume. So this is now the volume that I've realized earlier, my intercept color inverted. I also have my gradient color inverted. So let's go back to our workflow once again. I've done my intercept and gradient. I've done the color inversion of my intercept and gradient. Now I'm going to EEI chi volume. So I told you earlier that you need to be careful with the best chi at the well and the apparent chi in the seismic dataset. This tool here will allow you to analyze the apparent chi in your dataset. So first you can select your intercept. The tool works with impedance or reflectivity, so you can bring your intercept in reflectivity if you wish to. But here I've selected my intercept color inverted and gradient color inverted, so I'm now in impedance. You can also select a top and a base if you wish to refine your analysis. And for the plot, I'm just going to increase the step so I have something that my machine can manage for this video. So now you can click refresh and the tool will plot intercept and gradient values from our seismic dataset. You have like the similar display that we saw in EEI angle analysis, so the arrow and the plane that highlight the chi projection. Like in EEI angle analysis, you can manipulate the arrow in the plot to have your chi projection. You can use the slider, or you can type the value, like 30. So for the output, you can either select a single angle. If you wish to create only the angle that you've seen at the well, you can do that. But what we highly recommend is to select multi-angle. What I usually do for my work is I select -90 to 90 and I create every 5 or 10. So then I can screen for the apparent best chi in my seismic dataset. What we can also do is select a surface like this one that I'm going to show you. So it's my top reservoir, but just shifted a little bit, so 5 milliseconds or so within my reservoir, so I know I'm in my reservoir. You can also create a new surfaces that goes through the peak or the trough of your reservoir. And this here, if you select your surface, the tool will create attribute for each chi projection, and you will have the chi projection for new attribute for each chi projection on this location, on these surfaces. The tool also allows you to normalize, which is quite nice because if you see the difference in amplitude range between my intercept and my gradient, you can see right away that my gradient has brighter amplitude. If you normalize, this will mean that all your chi projection will have a similar range of amplitude, and it will be more easier to analyze your apparent best chi projection in your seismic dataset. So this is something I've done earlier, and this was the results. So I have now, as virtual volumes, all my EEI chi projections. I also have this chi projection as new attributes on my surfaces. So what we can do now is go into an interpretation window and select an interpretation, a line that goes through a well or multiple wells, and then analyze our chi projection. So I've done some screenshot earlier. So this is my EEI chi -90, -50. So you can see the difference already. So between -90 and -90 and -50, -30, 0, and chi 10, chi 30, and chi 30. So here what you want to highlight is the behavior. For the chi here, for the chi 10, it seems that it's the best between the 0 and 30 that highlights my saturated reservoir. Another way of having a look at this data, it's by using the surfaces. So let me just bring my 2D windows. So I've set up 2D windows with different chi projection. On this 2D window, I will be able to highlight maybe my channel if I have a channel, or my contact if I have a well-known contact. So now I can just tile my windows. And here I have different chi projection, -90, -70. So I don't know if you can see the numbers, but it's from the -90 to EEI 40. So right away, we can see that the best chi projection that seem to highlight our saturated reservoir is between 10 and 20. 15 seems to be a very good compromise between the 10 and the 20. So just as a reminder, the best chi projection at the well was at around 30, but in your seismic, the best chi projection is more around 15. This is a very well-known behavior that your best chi projection has a lower angle. So, as a conclusion, what we did, we used EEI angle analysis to have the best chi projection at the well to highlight fluid effect and lithology effect. Then we jumped into our seismic world and we created intercept and gradient. what I highly recommend is to make use of the virtual volumes and test different methods, different regression, and so on. Then we did a color inversion. Again, make use of the virtual realization for the parameterization of your filter and look at your data. What your impedance means geology, so it needs to be geological. Then we went to EEI chi volume. We use the well knowledge as a guide, but the goal is to find the apparent chi, which usually is maybe different from the best chi at the well. So again, you have to look at your data. So this is the end of today's video. Thank you for watching. We love your feedback, so let us know what you want to see. If you have any question, so you can ask them in the question tab in GoToWebinar. If we don't have time, please send us to either the webinar at sigal.com or support.geo@sigal.com. Don't forget to register for the next video, which will be on Wednesday, and this topic will be highlights reel of Blueback Toolbox, 5 tools to change your life. Do you have any question or do you have time for question? We have 4 minutes for question if you have any questions. There is some questions. So could you quickly show how to select multiple wells in both EEI and color inversion window? So for this project, I have only one well, but it's very easy. You just have to, so either EEI analysis, you just have to use either the drop-down menu and select multiple wells, or you can use the well over there. In well, select your wells and use the blue arrows. So we have a question, what are the reasons for different chi well versus seismic? The main difference is we have in our seismic noises that we can't quantify. And because we have noise that we can't quantify, most of the time the gradient is very noisy. And when we combine intercept and gradient, we're going to bring the noise from the gradient. So this is one of the reasons for the difference between chi projection at the well and chi projection in your seismic dataset. Pat Connolly did a very nice talk at the AAG in 2017 about this. I think the talk was called Chi. Let us know if you want this paper, we can send it to you. So what is the difference between the CI of the intercept and gradient? So the main difference will be if you go to intercept color inversion, it will be the volume that we select for the seismic spectrum over there. So here I've selected intercept. Once I want to do the operator for my gradient, I will have to use the gradient. Just remind or keep in mind that I'm doing the color inversion for doing a chi projection later on. So I'm going to combine them. So I need to have the same F1, F2, F3, and F4. So my recommendation will be to first start with your worst volume, which is usually your gradient. Try to find the best operator for your gradient. And then when you want to go to your intercept, select your intercept volume, but select the same corner point as your gradient. So I have, why do you create gradient and intercept CI volume instead of just doing the color inversion of your EEI volume? So I think from a mathematical point of view, there is no difference between doing the intercept gradient then chi projection. So you will have a chi projection in reflectivity, and then doing the color inversion on your chi projection, then you will have an EEI chi volume. I just have, I do this because it's very common to have a difference in spectrum between your intercept and gradient. So the color inversion allows me to have to filter my intercept and gradient before doing my Chi projection, especially if I want to do like an Odyssey project. So Odyssey is our inversion tool, and it can use multiple Chi projection volumes, but those volumes need to have a very similar spectrum. So if I don't combine my intercept and gradient early on, I can have Chi projection volumes that have different spectrum, and this will not help me for my Odyssey projects. I think it's time to end the video. There's still some question. Don't worry, we will answer the question through emails. Again, thank you very much for watching, and do not forget to register for Wednesday video. Thank you very much.